This view focuses on small channels formed on the floor of the much larger Casey Valleys, one of the largest outflow channels on Mars. The enormous floods that formed such channels sometimes flowed around either side of topographic rises, forming islands with a streamlined shape. The channels seen here are located on the trailing edge of such a formation. The small channels formed linear, coalescing pits, perhaps by ground ice sublimating into the atmosphere, leaving the surface material to collapse. Much of the remaining material seems to be made up of easily eroded sediments likely deposited by the floodwaters, which have subsequently formed dunes inside the channels. Casey Valleys extends almost 1,600 kilometers across the surface towards the northeast before it empties into Planitia in the northern lowlands of Mars. It's been known for a long time that there's water on Mars, and that some of it is at the surface. Recurring slope lineae are features that appear on Mars seasonally and have been shown to have salts from briny water associated with them. This means that water is in its liquid form and is flowing at the surface of Mars today. According to NASA, the likely mechanism enabling liquid water to exist is a process called deliquescence, where the salts absorb water from the atmosphere and then release it periodically. The surface of Mars today is an extremely deadly place for life, being exposed to ultraviolet radiation that will kill anything pretty quickly. So, does this mean life is still possible on Mars? Well, it all depends on where the water that life requires comes from. In this case, the water is all at the surface. So, any life will be trying to survive in a very harsh environment. But another possibility is that it could be from aquifers, the plumbing system in the rock that feeds these seasonal streams. If so, there might be regions near the surface where the conditions for life exist, which are protected from radiation. And even though the water on Mars appears to be very salty, we do know of extremophiles that are able to live in incredibly salty environments. When they form, impact craters dig up material from below the surface and throw it outwards into what geologists call an ejecta blanket. The fastest ejected material travels the furthest. So, material from different depths can end up at different distances from the crater. This observation shows a pedestal crater in Arcadia Planitia that has material of different brightness and color at various distances from the crater. This could tell us more about the material that's buried below the surface here. But the situation is complex. These pedestal craters have been significantly eroded so that not all parts of the ejected blanket are equally preserved. A detailed geologic map of features like this can often tease these confounding factors apart and tell us more about what's under the surface of Mars.